Alrighty, so if you are watching this is day 3 of the immune system lectures. We've only been getting a little bit each day, so there's not a ton of new stuff I'm going to add in. If you usually are in person and you just happen to miss an in-person day, I would go back to the last video because both classes are slightly behind where I have the online videos. So just a quick review of what's going on. We're talking about the immune system. We originally talked about components of the blood. You've got plasma, which is the liquid. Red blood cells carries nutrients and oxygen and carbon dioxide. White blood cells is our main focus because that main purpose is to fight disease. Platelets help clot blood. Plasma also plays a role in the immune system, which I will remind you of in this continued review. So, the immune system. 2 functions. It is to shield the body from pathogens and protect once pathogens have entered the body. You have already written this down. As I said, this part's just review, so don't freak out that I'm going super fast. It's just to remind you where we're at. The cells of the immune system. We have white blood cells, which are also called leukocytes. And there's 2 types of white blood cells that we kind of care about. We've got, just kidding. Mix something up here. White blood cells, leukocytes. That includes phagocytes. And a type of phagocyte is a macrophage. Phagocyte is just a broad term for a cell that will engulf another cell. So lymphocytes, that's where we've got 2 types of cells. We have B cells that make antibodies and T cells that kill antigens. So keep that in mind. The basics of how the immune system works. Well, first what happens is an antigen enters the body. I was talking to one class and they were kind of confused with antigen versus pathogen. Antigen is on a pathogen. An antigen is the proteins that give that defined shape to that pathogen. A lot of this PowerPoint, it uses them interchangeably. Antigens are think of it as like the fingerprint of the bacteria or the virus. It is how it is identified. So an antigen enters the body. The macrophage will eat the antigen, so to speak. So macrophages are just kind of floating around and they're like, ooh, that doesn't look like it belongs here. So it eats it, as you do when something doesn't belong there. And it's like, all right, cool. So this thing that doesn't belong here, I now know what it looks like. I now know how to identify it. So it tells the B cells and T shells, Sally sells seashells by the seashore. It tells the B cells and the T cells that shape. And what the B cells will then do is be like, cool, I got the shape. It becomes a plasma cells, and then the plasma cell produces antibodies. The antibodies then go out and will tag the antigen. So they are very specifically made with that shape in mind, and they will fit like a lock and key into that shape. And so they'll floop onto the antigen. And basically what that involves is they're holding it in place and screaming, not literally, but essentially screaming, so that the T cells is like, ooh, there's one. And the T cell will go to where the antibody is and destroy the antigen. If it's too big, the T cell will tag it for the macrophage to deal with. But in simple forms, that is what happens. So again, you should have already written this, so we're going through it real quick. The thymus is basically the educational facility for T cells. The liver. The liver filters the blood, and it's responsible for synthesizing proteins. So it has a lot of phagocytic cells, and that's because the blood travels through the liver, so it's good to have cells that, will recognize when something doesn't belong. Bone marrow. Bone marrow is where baby blood cells are born. Essentially, this is where immune system cells begin their cell development. And I believe that is where the last video left off. Bone marrow is where cells of the immune system begin their development. So, the next one we've got up is tonsils. Now, tonsils are a collection of lymphocytes in the throat. A lot of people have their tonsils removed due to different infections. It used to be really common that just everybody had their tonsils removed. We've now realized that they do matter. Like, if they aren't being infected frequently, it's best not to remove them. But they exist. But again, what they are, collection of lymphocytes in the throat. And so they'll monitor bacteria when they enter. Your throat is an easy passageway for bacteria and viruses because you have a lot of orifices in your face. You do a lot of breathing, and breathing is well known for bringing in bacteria and viruses that your body doesn't want. So it's good to have something in the throat that's like, yo, that's not a thing, that shouldn't be there, and can take care of it right away. If you need to pause to write that down, do so. The next one is lymph nodes. Now you have lymph nodes all over your body. I think you have some in your armpits, but you have some in your throat too. And what they are is a collection of B lymphocytes and T lymphocytes throughout the body. If you go to the doctor when you're sick, they'll often feel your neck, and what they're feeling for is swollen lymph nodes, because that's a sign that you're sick. If you're sick, your body's producing extra B cells and T cells to, fight this disease, and because of that, there'll be more there. It's not where B cells and T cells are made, it's just where they'll congregate to communicate with each other. So if they need to exchange information, they will gather at lymph nodes. Pause if need be. Floop. All right, next we have the spleen. So the spleen is a collection of T lymphocytes and B lymphocytes and monocytes. And the spleen also filters the blood. So it allows for this place of interaction of cells of the immune system. Again, I'll give you a second to pause. Next, we have the blood. Yes, blood is an organ. We usually don't think of it as an organ because it's not our thought. Like, when we think organs, we think stomach and liver and things like that. But blood is an organ. And it's an important one in the immune system because it carries around the cells and proteins of the immune system from one part of the body to another. Without blood, you would have an infection in your foot, and the immune system cells wouldn't be able to get there. Granted, without blood, you would have many other problems than your immune system not being able to function. But without blood, there's no transportation system. So that's the big thing, is it'll carry the cells where the immune system cells where they need to go. Awesome. So that ends this section of notes. I think both of these are videos. Yeah, we'll do that on the next round. So, that finishes section 3 of immune system notes. I hope you have a great day. If I know how to end this.